The SEA projects are three complementary projects that are funded by Euro HPC joint undertaking. The goal of those projects is to address challenges that we are facing when trying to realize exascale computing. IOC is focusing on data management and also storage, so dealing about how to properly move data around an heterogeneous system. The DEEPSEA project addresses computer heterogeneity, so how we are combining CPUs, graphic cards, other kinds of accelerators, and also very diverse memory technologies, and how this heterogeneity needs to be dealt with by the software stack, by the programming model, and also by the applications. Finally, REFSE is addressing the network technology, so how to interconnect in a huge system, how to make a machine which is scalable and has a good communication performance between all the components.
The IOC project is dealing with concerns about the future IOs made on some exascale system. Such large exascale machines will produce a very different workloads than what we have today. Exabytes stored, and in this scope, the actual paradigms that are currently in use, such as parallel file system, may not scale up to the exascale. And we may encounter some structural problems. In order to deal with that, we have to rethink the storage and the way the storage is done, and introducing new ideas and new paradigms.
REFSE is investigating the network interconnect. It's the backbone of supercomputers, connecting together the computer nodes. So to reach the exascale with a reasonable power consumption, exascale supercomputers will need to include a huge number of nodes. So we estimate by 2023 and 2024, there will be hybrid nodes, supercomputing nodes, hybrid, integrating GPUs and CPUs. Because this kind of hybrid, there will need many network interfaces to match the GPU throughput and the memory bandwidth.
DEEPSEA is the continuation of the series of the DEEP projects. The goal of DEEPSEA is to improve the software stack for such a machine. So to make that the lower layers of the software stack are very much aware of the specific hardware configuration of each one of the modules and how they are interconnected with each other, but that the middleware takes care of this complexity and is not transferred directly to the user. So the user is facing the standard programming environment, standard MPI, standard OpenMP, and they don't need to deal with all the complexity that is underneath.
The key value of the SEA projects is their shared vision. I mean, together they cover a wide range of the technologies necessary to reach the exascale, and they cover that with a consistent set of solutions from software stack to storage management, including also interconnect network. And this consistency is a key asset to drive adoption of the SEA technologies by the European HPC industry, and a key asset to really make a difference in the European HPC landscape in the near future.